Solving and graphing one-step inequalities. The goal is to be able to solve and graph any one-step inequality. And remember, given the operations, you have the inverse. For all addition, our inverse is to subtract. Operation, our inverse is to add. Multiply has a division inverse, and when we divide, we're supposed to multiply as our inverse. So, to solve inequalities with addition and subtraction, it is the same as solving with equations. You must do the same to both sides of our sign. So that line would be right here. So if I have addition, I identified this as addition, so I know I'm supposed to subtract 5 on both sides. That cancels out. X is less than 2. So I can test this if I'm picking 1. 1 is less than 2. If I say 1 plus 5, that gives me a 6 back, and 6 is less than 7, which is true. So when I graph that, I have 0, 1, 2, 3, and 4. I have an open circle at 2 pointing to the left. I identify my negative. That means I am subtracting this 2. I'm going to do the opposite by adding it to both sides. M is greater than or equal to negative 6 plus 2. Have opposite signs. When they're different signs, we're going to subtract. 6 is bigger, it's negative, so my answer is negative, and 6 minus 2 is 4. So when I have negative 2, and I'm just picking numbers that ends up with a negative 4 on my number line. It doesn't matter what numbers you use. I know I have a closed circle pointing to the right. I identify I have addition, so I'm going to do my inverse of subtracting. P comes down, my sign comes down, and 10 minus 3 is 7. And I kept referring back to this pattern of having your variable on the left and your number on the right. So if I'm going to flip this whole inequality, my inequality is pointing to my 7, or you can think about that alligator eating the P. So if I flip this entire inequality, my alligator still has to be open eating the P. Or I think of if it's directed, if it's pointing at the 7, if it flips, it still has to point to the 7. So when I graph this, there's no question about what direction I'm supposed to actually graph this. So don't accidentally graph this one. It is supposed to be this one, with my variable on my left, my constant on the right. My inequality sign is pointing to the right. Excuse me. So I have subtraction 4. I'm going to add 4 to both sides. C is less than or equal to 13. Closed circle, pointing to the left. I have subtraction 11, so I'm going to add 11 to both sides. K is greater than 11 minus 5 is 6. Open circle at 6, pointing to the right. I have subtraction 1, so I'm going to add 1 to both sides. 8 plus 1 is 9. And this is the same thing. My variable is on the right. I'm going to flip it to my left, and if it is pointing at my variable, I want it continually pointing at my variable. Again, this one up here is pointing to my constant, so when I flip the inequality, it has to continue pointing to the inequality, or to the constant. This one, if my inequality sign is pointing to my variable, when I flip the inequality, it has to continue pointing to my variable. So when I graph this, I have an open circle, and my graph goes to the left. So this one, you might be tempted to graph this pointing to the right, but again, it has to be in this format. It has to have the variable on the left, then the inequality sign, then the constant. So remember, identify the operation, apply the inverse to both sides, And do not flip the sign until the end. So notice all of these. My less than sign stayed less than. That sign was greater than or equal to, remained greater than or equal to. So on and so forth. Less than or equal to, less than or equal to, greater than, greater than. The only ones I switched were the ones that had the variable on the right when I want that on the left. So don't flip the sign until the end to get it into this pattern. Variable, inequality sign, and the constant. Make sure you flip the entire inequality. For inequalities that have multiplication and division, it is not the same as equations. The direction of these inequality signs will always switch. So take this example, looking at this example. So I have 3 is less than 5, which is true. But if I multiply -1 to both sides, which is still true because I'm doing the same to both sides, I get -3 is less than -5, which is false. We know it's larger. We know -3 is larger than -5 because it's closer to 0. It's farther right on the number line. So this is the true statement. Therefore, you must switch the sign for multiplying and dividing positives and negatives. So I identify that I have multiplication right here. So I'm going to divide 3 on both sides. I do not flip my sign because I did not divide by a negative. So I'm going to have an open circle at 5 pointing to the left. Identify this as multiplication, so I'm going to divide by a +2, therefore my sign does not switch. I have a closed circle at 13 pointing to the right. This one, I divide by a -5, which means that has to switch to get my -6. So I have an open circle at -6 pointing to the right. I'm dividing by a negative, so I know my sign is going to switch when I divide both sides by my -4. This switches, and I get 21. Open circle at 21, pointing to the right. I identify this as division, so I'm going to multiply out my 3's on both sides. I get 24 is less than x, and again, I need my variable on the left and my constant on the right. It is pointing to my constant, therefore when I rotate it, when I flip it, it has to continue pointing to my constant. So I have an open circle at 24 pointing to the right. So this one is a negative x over 9, so I'm going to multiply by my -9. That negative and that negative are going to cancel out, and those 9's are going to cancel out. So I get -90 is greater than x because I multiplied by that negative. So I'm going to switch this around. It's pointing to my variable. I'm going to maintain that. Open circle at -90, shading everything to the left. So I multiplied by a negative, therefore my sign has to switch directions. And it looks like it stayed the same, but it switched directions again because I flipped my entire inequality. So I don't do this until the very end. I solve it, and then I need to decide if I'm going to flip it to put my variable on the left. So I identify this as multiplying. I'm going to divide by 3 on both sides. I did not divide by a negative, so my sign stays the same. 9 divided by 3 is 3. I'm going to flip this around. It is pointing to my variable, therefore it's going to continue pointing to my variable. And that just helps me know that's my graph. Open circle at 3, going to the left. Dividing by -3 because I identified this as multiplying. I divided by a negative, so my sign must switch. It is pointing to my variable, so it needs to continue pointing to my variable when I flip it around. Open circle at -3, pointing to the left. I'm going to multiply by 7. X does not switch because I multiplied by a +7. 4 times 7 is 28. Open circle of 28. Shading to the right. So to recap, identify the operation and apply the inverse. Only flip if you're multiplying or dividing by a negative. And you can always flip the inequality to help your graphing to put it in this form, the variable, then the inequality, and the constant. Make sure that if you do this step, the original direction, it needs to maintain that integrity. So if it is pointing to your variable and you flip your inequality, it needs to keep pointing to your variable. Same thing here. It is pointing to my constant. So when I flip this inequality, it has to continue pointing to my constant. Refer back to your pathway for your summary questions.